Hello everyone, welcome to shoe cameraing green robot sign source code. This is bootstrapping open source. Oh, there we go. I'm Jake Wharton. I work at Square. I do Android there, also a little bit of Java, and a lot of our open source work. Alright, so we're going to do a little open source speed dating. I'm going to introduce you to eight libraries. Really quickly, we'll go over the use cases and how to use them, APIs and the advantages. We'll go through how paying with Square Wallet, how many open source libraries that we touch just trying to pay at a merchant, why you should be open sourcing your code, and finally I will throw in a very short shameless plug for Square. So first up is ActionBarSherlock. How many of you guys have heard of this? How many of you guys are using this? All right, quite a few. So if you haven't heard, this is a backport of the ActionBar, and it goes back through Android 2.1. And that covers about 96% of all devices on the Play, last I checked. It mirrors the API, the ICS version of the API exactly. It does require that you duplicate your theme attributes. This is due to a limitation in the C code that loads resources. And it acts as an extension of the support library, so it depends directly on the support library. And you can leverage it with fragments, loaders, and all the affordances of the support library. It also comes with backports of Search View and the Share Action Provider widgets. So how do we interact with it? For the native action bar, you would just call get action bar and use any of the APIs. It's very straightforward. When switching to ActionBarSherlock, all you have to do is call get support action bar. As I said, the APIs are exactly the same. So in creating action items, which is the main thing you probably want to do if you're using the action bar, it uses the standard menu system. So this is constructing a menu with the native action bar, and this is constructing it with ActionBarSherlock. So I don't know if you saw what changed, but all that changed was the get menu inflator call in onCreateOptions menu just became get support menu inflator. Everything else is exactly the same. Except, rather than importing these, you are now importing these. So the API is exactly the same, just exists in a different package. Theming, so this would be the native action bar where you're supplying a style, and then we're showing a logo and supplying the logo. To use something like this with ActionBarSherlock, here's where we see the duplicated theme resources. And there's the style. So what this gets you is on ICS, you have this lovely action bar. And now on 2.3 running on an XSS, we see the same exact thing. If you want more information about this, abs.io is the website. So view page indicator. How many of you have heard of this? Using? All right. So this is usually the only indication that swiping is available on a screen. If you're just using a view pager, it's not always obvious that the user can swipe left or right. You also can provide context as to the current page you're on with a title or an icon. And it just looks nice. A lot of people comment on the Play Store, which was one of the first to have this UI. So it's really simple to use. This is setting up a view pager, normal stuff, and then to hook up the indicator, you just find it and tell it where the pager is. In your XML, you just throw a view in parallel with your view pager, and what you get are these potentially 5 different beautiful indicators. So in the lower left, we have icons, and then moving to the right, we have titles. At the bottom are lines, tabs, and then an underline, which acts sort of like the launcher on ICS. And if you'd like more information, viewpageindicator.com. So 9-1 Androids. How many of you have heard of this? And are any of you using this? All right, that's surprising. So this is a backport of the new animation framework. It does have limitations, but those limitations exist in the older versions of the platform, not the library itself. It's most useful for transition animations, so when something's coming in or out of the screen, or you're moving something from one place to another, and then it's going to remain at that location. So this is a call. This is code that's copied from one of the API demos that come with the new animation API. And if we were to change this to work on, or work with 9-old Androids, it would look like this. So this is the old one, and this is the new one. Did anyone notice anything change? It's because it didn't. So here's what the imports now. Importing the animation package, and now with 9-old Androids. This API is exactly the same. All you have to do is change your imports, include the jar, your ICS and up style, or 3.2 and up style animation will now work from Android 1.0 to Android 4.2. And yes, I have tested this on Android 1.0. This is the API demos that are on ICS and up running on an Android 1.0 emulator. So another nice feature about the new animation library is this view property animator. And if you guys have seen the talks from I.O. Or other talks here, Chet has talked about this in quite length. And this is with 9-old Androids. It's not quite as elegant, but obviously we don't have extension methods or any way to add a method onto the view class. So you basically wrap your view with a static import of the animate, and then you get that nice fluent API. And this will delegate to the native view property animator when it is available, so that you get the affordances of the choreographer on 4.1 and up. And of course, 9oldanroids.com. So I've talked about those libraries a lot, and there's a lot of documented stuff on those. So Auto is a relatively new library. This comes from Square. So we forked this from Guava's event bus. The event bus in Guava is great. It's very battle tested. It's not so great on Android though. It has a lot of things which only work well on desktop Java. We also added thread enforcement to the API. So by default, it enforces that all interactions with the API occur in the main thread. And this is so that you get thread safety by default. You don't want to have something operating on a background thread, sending posts to something listening in an activity, and you then try and make a change on the view. And obviously, you can't do that from a background thread. You can turn this off if you really know what you're doing, but by default, we thread confine it to the main thread. So the other thing we added, or rather got rid of, was walking the class hierarchy, looking for event producers and event subscribers. And that's because reflection on Android and walking the class hierarchy on Android is rather slow. So this is a basic event dispatching system. So if you want to listen to an event, you have a method which takes the event type as its sole parameter and has a subscribe annotation. In order to get events, all you have to do is call register with the instance. And then if you want to send an event, all you have to do is call post and create this instance. So this is a great way of decoupling your logic and your views in order to provide a way of creating, I'll show you. Multi-pane layouts work really well with this because you decouple the communication between fragment and activity, fragment to fragment. They don't have to know to whom they're communicating. All they know is that they're posting events and that hopefully somebody's listening. So a good use case here would be something that's listening to location updates. So say you have a service which is receiving the Android callbacks for locations. So what it can do is keep track of the last best known location and store that in an instance variable. And then it can also have a method which is annotated with produce and has a return type of the location event. So now, if we go back, when we call register here, if that producer is already registered on the bus, so that service has registered itself, as soon as we call register here, that producer will be called to get the last best known location, and it will instantly call the subscriber here with the location. So you can imagine if you're setting up fragments or views which have location-based information, whenever you inflate them and attach them and they each register on the bus, each one is now receiving the best known location. You don't have to trickle it down through your view hierarchy or fragments activity. It just receives them. So this is great for decoupling things when you have multi-pane layouts. So here, when we click on Matthias, we would post an event. And then because we're in a single pane layout, the activity is going to be listening to this event. And it will know we're in a single pane layout, and it will know to start either a new activity or do a fragment swap. So if we're in a multi-pane layout, what would happen is rather than swapping or starting a new activity, we would just swap the adjacent fragment. So the two different behaviors all happen with the same event, and the logic is consolidated in the activity. So fragments should be encapsulated and only know about the views to which they contribute. They should not be knowing about whether or not another fragment is present. So auto allows for this great decoupling of this logic. And if you'd like more information on this, here's the website. So Dagger. Dagger is a new JSR 330 implementation. It uses APT, which is the annotation processing tool. It runs at compile time through Java-C, and traditional dependency injection frameworks use reflection at runtime to determine which dependencies to resolve and produce. But by doing this during the compile step, we can figure out the dependency graph up front and create the things which will perform the injection. So this way, on Android, because reflection is so slow, we eliminate that altogether. And there are little helpers in this for Android, so it will parse your manifest and already set up injection points for all your activities. So if any of you have been exposed to dependency injection frameworks, you basically create modules which produce your dependencies. So here I'm creating a singleton bus with auto, and then I'm providing some cool things. So if I want to use these now, I have to set up my object graph, and this is a graph of all the dependencies. So I add all the modules. So I have my this module I just created, I have that module, and then the activity module, which is the helper that I get. This is the ugly part. So in your base activity, you need to perform injection. So rather than doing this manually in every activity, just shove it in a base activity, you'll never have to look at it again. So what we get out of this is now in our activities, we can just create members which have @inject annotations. And after we call super on create and it goes to that base activity, all our dependencies will have been satisfied by now. So we can do cool things and we can post cool thing events without having to worry about where those dependencies came from. And URL if you would like to find more information. So Retrofit is a new library. It actually has not had a version yet. It's about to hit 1.0. It allows you to define HTTP REST endpoints as interfaces. And it's similar to JAX-RS. It's very declarative. And the best part is that it's type safe and it has pluggable converters. So if you use JSON, Jackson, XML, protocol buffers, all of that is pluggable. So let's say we want to get some tweets. So I created a tweet class here, which has only the text. And then I'm going to create an interface. And this interface has a single method defined, which returns a list of tweets. It takes in a string, which has an @named annotation. That also comes from JSR 330. And then we just put a get on top of it, because we want to perform a get on status's user timeline, which is the Twitter endpoint. To use this, all we have to do is, after we've created a REST adapter class, which is the main API, there's a .create method, and we give it the class, and it will return us an instance. And all we have to do on that instance is call a method and pass a string, and we'll get a list of tweets back. Those will be deserialized by JSON. It'll throw an exception if there's any HTTP problems like authentication. And that's really nice, really simple. Basically 2 lines of code, and you're hitting an endpoint. It's type safe. But on Android, our application would blow up because we're doing something synchronously, likely on the main thread. So what Retrofit does is it allows you to pass the last argument as a callback. And that callback is a generic on the type that you want back. So we've moved our list tweets into the callback. Now when we make the call, we pass in the callback, and we get the tweets as the argument to that callback. So what happens here is when we call tweets, retrofit's gonna, your code's gonna move on because it's asynchronous. Retrofit is gonna make the call in a background thread. But when you get the callback, when the result comes back, retrofit will move that to the main thread so that whenever this callback is called, you can interact directly with views. So I sped through those last three because I want to tie them all together because they're really great together. So I'm going to provide a module here. I'm going to have the REST adapter, which sets up retrofit. I'm going to set up auto, the event bus, and then I'm going to create a provider for the tweet service that we previously constructed. So now in my activity, I'm injecting the tweet service and I'm injecting the auto bus. In my onCreate, or you probably wouldn't want to do this in onCreate, but as a result of a button call or something, we can now call tweets for the user, and when we get the callback, we post it directly to the bus. Because that callback comes back on the main thread, we can post straight to the bus, and that will go out to all the views. So if you have multiple fragments, views, a service, your adapter, and they're all listening to the tweets loaded event, they will all be updated at the same time when you get this callback. So all your views can just magically update. So one thing that's really good about abstracting your stuff behind these libraries is it allows you to do something really cool for testing. So with Dagger, we're creating what is called an overrides module, and this is basically providing something that you already provided, but it takes precedence. So we're gonna overwrite our tweet service with a test tweet service. And this test tweet service is basically just going to give us 3 objects that we have created. And what this means is when you enable this module, you're going to get, when you call that tweets method in your onCreate, you're going to get that callback with this test data. So imagine that you have, say, a JSON file that's filled with all of this test data for your model. So you can use JSON to deserialize that JSON into concrete objects, and then in these test services, you can return those, and you can create basically an entire backend for your app for testing. So this works great for if you're doing instrumentation tests and you always want known data. So at Square, we actually do this for both of our apps, and it lets us test the apps before the APIs are made, before the APIs are deployed. It lets us run instrumentation tests on known data, and that's really crucial because of sort of the fragility of instrumentation tests. So as you can see here, we have a list of presidents and Howard Schultz as our merchants, and then I'm logged in as Bart Simpson. And all of these accounts are created as basically JSON files, and they all get deserialized into the types and override all the callbacks. All right, tape. If you attended the talk by Bob last night, he talked about this. It's basically a file-based queue. It allows you to choose a serialization mechanism of your choice. Typically, so we use JSON. You can use object serialization too, or you could use any other format. And there's a few queue helpers in there for doing common tasks like serializing objects or creating a service. So this is a code that you see very often in a lot of apps. Basically, you have a task that you want to do. Say you want to post a tweet, charge a credit card, or post something to Google+. So what you do is you have a task which basically implements a runnable and performs that, and you would typically execute this on a background thread using an executor. The problem here is that there's no guarantee that this is going to complete, and the retry mechanism is all up to you. So if this fails, if your battery dies, if your network's spotty, if it throws an exception, it is all you to handle all those events. And there are quite a few that you have to handle, and most apps do get it very wrong. So what you can do using tape is change this so that it implements a task, which is a tape class. And then with that, you get a callback that you would provide. So rather than just running, this execute method takes that callback, and when that task has completed, you call a success method. And the success method reports back to the queue that this task has been completed, and it will be removed in a transactional atomic manner so that you can verify, or no matter what, that the task has completed. So if for some reason an exception is thrown, your device dies, the network goes down, you know that the next time that queue service is running, that task is still going to be there for you. So if any of you ever posted to Google+, Google+ is my favorite to pick on for this. You created a nice long post and you hit send and you don't have any network connectivity. So that post is probably going to be lost and you're going to have to retype it all because there's no durability on that. And if you'd like more information. Okay, so let's talk about a use case, paying with Square Wallet. So with Square Wallet, say I'm already logged in and I'm approaching a merchant. So how many open source projects are we going to hit just trying to pay for this merchant? So we start with Dagger. We use Dagger for everything. So we're going to inject basically a user. We need to find out who you are. So when you start up the app, the application will inject the user and we'll make sure that you're logged in. By doing that, or to do that, we use JSON to deserialize the information that's stored on the file system. Then we dispatch that across the system using auto. The UI shows up, so ActionBarSherlock is in use. So now we have to determine whether you're still logged in, and we have to get merchant information. So Retrofit's going to make a HTTP request to one or two endpoints. Behind that, we have OKHTTP, which is a sort of third-party HTTP client. It's actually the HTTP client that's in Android, just modified to exist as a standalone project. So Polexor is a Square library which allows us to communicate with a Python server called Thumbor. Thumbor is a server-side image resizing and compositing framework. It basically allows us to download images that are of the exact size that we need to display them at. So if we have a Galaxy Nexus next to a, HTC Wildfire, which is like 12 pixels, the HTC Wildfire doesn't have to download this ginormous image. So now to spawn, we clicked on a merchant now. We've gotten our callbacks. We see our image. We click on a merchant. We use this tiny activity compat to allow us to use the new Jelly Bean activity animations. That will be in the support library very soon. So now we need to display, we're paying at Starbucks because I wanted to hit another open source library. Starbucks uses QR codes for now. So we use Pony Crossing, which is our subset of Zebra Crossing. It's a library which allows you to generate barcodes of all different shapes, sizes, and sorts. And then finally, for opening a tab, closing a tab, or making the actual payment, we use tape to persist all tasks to the file system. So that way, if you're paying, you know that it has gone through, even if you have spotty network connectivity. And then finally, we show you a nice Jelly Bean style notification that doesn't crash on Android 3.2. So what about testing? How many of you guys actually test apps? Integration tests? What about instrumentation tests? Not many. So JUnit, obviously, we use to run a battery of integration tests. We use Fest, which is a Fluent API for determining assertions, or validating assertions, rather. Roboelectric, which nobody really likes, but does an amazing job of holding up the Android classes that don't exist on the JVM. Robotium for instrumentation tests. So this is a framework that allows you, it basically augments normal instrumentation tests and allows you to use a lot more dynamic and declarative language and clicking on buttons and determining whether or not text exists and typing things. It's really great. Mockito for creating mocks. This augments the test data that we use to load from using the Retrofit and Dagger. Sometimes you just need to mock out an Android call, or you just want to determine how many times a method has been called so you can spy on an object. Mock web server works great if you have things outside of Retrofit. So if you have an image downloading library or you're hitting things that don't need to go through your normal REST APIs. And then Spoon. Spoon is a Square library that is not yet open source. I had hoped it would have been by now, but we're going to talk about it. So Spoon is it's hard to describe. It facilitates instrumentation testing across a variety of devices, aggregates all the test results, and presents them in a meaningful way that allows you to interpret and see the results of your instrumentation tests very quickly and easily. So it also has an API for capturing screenshots and allows you to compare those screenshots across devices and across test runs. So it maintains a history of all the tests that you've run for a device and for a configuration of that device, and allows you to see the history. So if you have a single test that looks at an important activity in your app where the UI layout is very crucial and you want it to be pixel perfect across every single device, what Spoon will allow you to do is basically distribute your instrumentation tests across all these devices in an automated way and run them continually, so that over the course of, say, a month, you can make sure that this activity looks the same on all devices, hasn't changed, and that you haven't introduced any bugs on some LDPI Android 2.2 device that nobody tests on. So this is a picture of it running on 2 devices. This is going through our instrumentation tests. You can almost see the mock data. George Washington's in there. It produces an output. This is a high-level output. It's meant to be displayed on something like a information radiator on a wall. Basically gives you a high-level view of whether or not all your tests are passing and on which devices tests are passing or not. So if you see a vertical, this was a really bad run. Vertical color correlation indicates that a test is failing on all devices. What you want to look for here is finding, say, if you had 4 devices and there's a single red line on only one device, whereas the rest of the column is green. So that would be a test that has failed only on one device, and that would you should look into that more. So if you hover your mouse over these, there's pop-ups which tell you more information about the test, timing, the name of it, and then if you click through to the device name, you get a screen that looks like this. It gives you a vertical view of each test and then a horizontal view of all the screenshots that were taken during that test. When you take a screenshot, you annotate it with or rather you give it a name, and that name needs to be consistent. That's how it maintains the history of all these. Let me scroll up here. So you can see at this test at the bottom, we started with 3 buttons, and then I clicked a button and it displays hello. So this would be something that you could test across all the devices and say in different languages and make sure that that hello text wasn't wrapping. I didn't want to go forward. This was supposed to be open source by now. It's almost done, and tragically there's a new UI automation framework which they just announced 2 days ago. So it probably will delay the open sourcing of this so we can get support for that in, or maybe not. But you should definitely look for it soon. Testing is something that's not done well enough on Android, and while Spoon doesn't make it any easier to write instrumentation tests, it allows you to much more easily see the results of those instrumentation tests. What we use this for primarily is checking out designs. So our designers obviously are not going to be keen enough to go and run instrumentation tests themselves. So this allows us to report and show information on large screens around the office where the designers can see how their designs look on the devices that we'd never test. So I'm going to talk about why you should open source libraries. And I'm going to do so, I actually gave a brief 5-minute talk to Square Engineering about this. And I thought it was pretty effective. And it uses a means that I hope you all can relate with. So it's all memes. And if you want to look at the talk, there's a link at the end. So basically, Square itself is built on open source. And that's not even on Android. Our backend is primarily Java, and the dependency list for it includes no less than 40 or 50 open source projects. And that doesn't include all the Ruby and JavaScript stuff that we do. In Android, we pull in a ton, as you saw, just for a simple thing as paying with Square Wallet. So because Square doesn't exist without open source, we believe very much to our core that we should be contributing back to the open source community, which is why we spend so much time on things like auto tape and retrofit, because it allows you to make your apps better. Android apps traditionally have sucked really badly, and what you use from the open source community can alleviate some of the pain of creating Android apps, and it lets you focus on the actual content. So if you have a library which is doing dependency injection, marshalling your REST requests, persisting your tasks to disk so that they never go down, backporting the action bar so you don't have to worry about juggling two versions of the framework, it really frees you up to hone and basically harden your app to be the best that it can be for the content, because that's what really matters. No developer wants to lose a day or a week on some library, writing some library that's persisting tasks to disks. It shouldn't have to be done over and over again. So you should be thinking about open sourcing stuff like this, because there's still giant gaps. There's tons of things that have not been implemented. A huge one that I think most developers can hopefully relate to is loading images in a list and caching and resizing and transforming them. There's a million images in Square's apps, and in just about every app that I use, there's image loading. And this is a big pain point because there's a lot of things to get wrong, and there's a lot of ways to get tripped up. And there's no good library for that. And that's just one example. There's probably hundreds of other ones that all of you run into. And the sad part is that I bet a lot of you in here have written things to do that and have not open sourced them. And that's fine, maybe because they're not generic enough. But you should consider spending the time to put in that extra 20% and open source a project. Because what that does is that lets us create a better world of apps. And since we live in that world, that's going to benefit not only you, but everybody. So the talk's like 20 slides. It's all memes. And they're kind of funny, at least I think so. So if you would like to see that, you can go to this website. So very briefly, Square loves Android and Java, and we love open source. So if any of that stuff is interesting to you, there's the website. Love to work with you. Oh no, there's the website. Any questions? RoboJuice? How does Dagger compare to RoboJuice? So RoboJuice is just Android helpers built on top of Juice. And they're actually not super related to dependency injection. They have like view injection and fragment injection. Those things actually aren't dependencies. They're sort of just helpers. So view injection is the one that almost everybody brings up and has been asked about Dagger many times. You can basically write view injection in about 5 lines of code in your base activity. All you have to do is search for the annotations that are inject view and call find view by ID. It's very trivial. So Dagger doesn't include anything like that. It also is applicable to the server-side world as well. It wasn't designed with just Android in mind. The JSR itself mentions the annotation processing tool as a potential avenue for an implementation. It had just not been done. So what this does is, what we're trying to do with it is basically create something that's applicable to both Java and Android. And you get a lot of benefits out of that through the code gen. It produces actual code, so that means when you're debugging your app, you can step through the injection because it's just Java code. If you're using something like Juice, since it's heavily reflection-based, you're going to be deep down in classes all through reflection, having to keep track of that stuff yourself. So if you're finding RoboJuice, if you use RoboJuice, I mean, there's certainly nothing wrong with it. It's just Dagger was created to avoid the runtime reflection and the annotation reading at runtime, because on Android that's traditionally been a huge pain point. And even though it's a lot better, it's still quite slow. So that's the primary goal. Anybody else? Oh. So the question was what about depending on multiple libraries like this, and how do you handle that case? So traditionally, it's quite a pain with Ant. I've been a long time Ant basher. Android system compilation system has been around for a long time, and this was before library projects existed, before people needed to pull in all these dependencies. Thankfully, it is being rewritten, and it will support native dependency resolution. So for now, it's definitely it's still going to be painful. There's a lot of manual dependency resolution. So a great example is if you're depending on ActionBarSherlock and say some other library project, both of which extend from the support library. So RoboJuice, that's a good example. So ActionBarSherlock and RoboJuice both depend on the support library. And sadly, both of them require you to have base activities. So there's a base activity in ActionBarSherlock, which you have to extend from. And there's a base activity in RoboJuice, which you want to extend from. And there's just traditionally been nothing to handle that. So you have to write these glue classes to pull these things together. And then additionally, the transitive dependencies on the support library are different. So if you pull both of them in blindly, you're going to get dex exceptions because they're different versions of the library. So what the transition to the new build system will afford us is it will know about, your dependencies will basically be a graph, and there's metadata about them. So it will know that the ActionBarSherlock dependency is maybe on an older version of the support library, but this other library you're pulling in is depending on the latest version, and it knows that that version trumps the one from ActionBarSherlock, so it will cut that out. If you're doing it all with Ant right now, your best bet is to manage the transitive dependencies yourself. So ActionBarSherlock comes with a support library, RoboJuice comes with it. I would get rid of both of them, copy them into your source tree, get rid of, or like your revision control, get rid of both the support libraries and copy in the latest one from the SDK. That way you can ensure that they're both exactly the same and that you're both getting the latest version. It's not pretty. It's pretty much the only way to do it though, at least until the new build system comes around, and that's still a long ways away. Any others? Like, it's hard to see. Does it handle the threading?
Yeah, the question, well, let me rephrase it. When you call retrofit, does the request in the background thread, right? Or you have to handle that?
No, so when you, I'm not even going to bother going back. When you create the REST adapter, which is the main class with which you create the services, it's a builder, so it has a bunch of things that you have to pass it. And one of those things is an executor on which the callbacks, or rather the HTTP calls, are called. And then you also give it an executor which brings things back to the main thread. So we provide an executor which knows about the Android main thread, and then you can do, Java has executors which gives you methods to create an executor, like a five-thread cache thread pool, things like that. So there is an example of that in the code, and there will be an Android example by the time it hits 1.0. So it runs all those in the background thread, and then the callback is on the other executor. Or if you're using something like loaders, which already handle putting stuff on a background thread and moving things back to the main thread, you can use the first example, which is the synchronous version, because it's already on a background thread. And then rather than the callbacks, you get stuff synchronously as a return value or an exception thrown, HTTP exception.
If you require HTTP flag, would you always recommend hooking HTTP, or are there disadvantages
So the good thing about using essentially third-party HTTP client is that it's consistent across all devices. And OKHTTP itself is the Android HTTP client under the hood. So any contributions that are made to OKHTTP get upstreamed into Android and vice versa. Traditionally, the HTTP situation has not been great because of the APIs of the old HTTP client and then URL connection. Neither of them are excellent. And the one in which the Android team is maintaining has changed. There's a blog post by Jesse Wilson on the Android developer blog about it. In addition, there's been bugs on certain platforms. So there's a thread pool reuse bug on Froyo, which can cause your connection pool to fill up with basically dead connections. So it's things like that. It's a lot easier to throw in an extra 50 to 100K in your APK to get a standalone HTTP client. That's going to be consistent across all devices, and you know it works. And then it also has additional features. So OKHTTP actually has speedy support. So if you have servers which know how to talk speedy, it supports that as well. Not to use the one built in? Oh, no, I would absolutely recommend it. Anybody else? I can't, it's hard to see.
Another question. Are you aware of any example open source project that would show the integration of all these great libraries together with practicing?
So there's a couple projects that are out there which use a lot of these. The GitHub app is actually a really great example of using a lot of open source libraries. There's also websites which allow you to basically bake an app using yeah, you were. No. So Android Kickstarter and Android Bootstrap are two websites which do a good job of pulling a lot of open source libraries in. And all the ones that I talked about today, all the open source libraries, there's plenty of alternatives. These are the ones we use because either they're done by Square or they're worked on by Square employees. There are alternatives to all of these, and that doesn't make them any less usable. As long as it's solving a problem that you have, use it and contribute back to it. You're going to find that it makes development of apps a lot easier when you have all these things done for you. It's a huge pain point for a lot of new developers to try and perform tasks which a lot of open source libraries do, and they just don't know to pull them in. So you really should be pulling them in and educating others to be using them because it makes development so much smoother. Any other questions? I think no. Yes. So we, at Square, we actually don't use any on-device databases. We serialize things to disk using JSON as JSON files. All our data, we do cache things locally, but at least with Square Wallet, all the merchant data is very location specific and time specific, so we always have to be querying for it. And then on the card reader, there's just not a lot of data. So we just serialize JSON to disk, and it works great. SQLite has been a pain point for a lot of developers, and I know there are great helpers out there. There's a few projects on GitHub that I follow for augmenting the APIs and dealing with SQLite, but I can't remember the names of them off the top of my head. Which ones? Which ones? So I'm not repeating questions, I forgot. the question is that by pulling in a lot of these libraries, compilation time goes way up. The problem there is mostly around AAPT and DEX are slow operations, and they're not incremental. So this is a problem that's being worked on. There's not a whole lot that you can do. Library projects now support being packaged with the Java classes compiled as class files. So that, but that's traditionally not the slow part. The slow part is generating all your R files, because for every library project, you have to generate a library project or an R file, even if those library projects depend on other library projects. And then dexing itself has been traditionally very CPU intensive and not the fastest operation. ActionBarSherlock is especially tough because all the resources of the action bar have to be duplicated. It is a very large library, relatively speaking. I would argue there that the cost of suffering the extended compilation time is worth the benefit of the library, because doing something like that yourself would be, it would waste a lot of your time. So they are working on, to answer your question, they are working on ways to speed that up. And I know there was a patch contributed to Dex itself, which is going to make caching, do some caching. Jesse Wilson just contributed that. I doubt it made it into the current tools. It's in 21? Okay, so you should update your tools. It'll be dexing will be a lot faster. I think that might be it. Oh.
Firstly, thanks for all the libraries, they're awesome. But secondly, what does Square use for image downloading?
So what does Square use for image downloading? We have our own library for it. The problem with it, and the reason that we have not open sourced anything around that, because that's something I really would love to do, is that it's deeply integrated with all of our internal stuff. So it knows about the user. It knows about it relies on dependency injection. It relies on all these things. And one of the sort of mantras that we do around open source is that libraries should be small, modular, and standalone. So we don't want to release a library that has a dependency on like dependency injection, because we don't want to require that someone using it use dependency injection, because image downloading traditionally shouldn't need something like that. But in the way we use it, it's of great benefit to have dependency injection. So that's sort of the main reason that we haven't released anything. There are tons of libraries that do image downloading, but I feel like they all cover 80%, and none of them get that last 20%. And it's all different 80% that they cover. There's not something that has the whole range. So I'm really hoping somebody releases one, or maybe we'll, if we ever buy some free time, I can try working on ours. But I feel like that's a huge pain point. Google actually mentioned that they have a library for this, that they were going to open source. That was at I/O. So, no? I think it was mentioned by Adam Powell. What? Oh, really? I guess it's in the I/O app. Anybody else? I can't really see up top. All right, well, thanks everybody for coming. Make sure you open source all your things.